Thanks for coming back. Good to see you all. I hope you enjoyed some really interesting conversations. I know I did, and thank you for those who, what's that? Oh. So earlier we talked and showed AccessMap multimodal in action on desktop. What we wanted to talk about for this session is the non-visual experience in AccessMap, which we worked on. So what you're seeing on the screen is a picture of the Tasker Center team, minus a couple of people. But these are all the people who've been involved in various aspects of the work, and I wanted to acknowledge everybody, and some of us are in the room, so thank you for the work that you do. I really appreciate that. So in talking about the non-visual experience in AccessMap today, you still can join the pilot, the AccessMap pilot that I was plugging earlier today, and still join in and have an opportunity to be in the raffle. So go to tinyurl.com, go AccessMap. So what we're going to talk about in this session, as I said, is how AccessMap multimodal can be used on the go and using the non-visual experience. So a non-visual experience was designed both for using the router prospectively before you actually go to the open environment and conduct your trip, but also during the trip, AccessMap can be helpful in providing step-by-step instructions, and that's what Kunal has designed the user experience for, and Sam in the back of the room executed and implemented the work. So what we're going to start with is actually a video of how AccessMap operates in the non-visual mode with screen reader capabilities overlaid on top of it. So what you'll hear is an odd sounding voice, perhaps, if you've never used screen readers before, and it speaks a lot faster because people are trying to consume a lot of visual information in a small amount of time. And I'll try to narrate where there are spaces that are not clear.
Trip plan, search, image, tasks, Seattle, main menu, see, tap, image, search, trip, menu, powered, walk slash, custom, edit trip, take a tour, map legend, start route, zoom in, start route from your location, start route from your location. Zoom in, start route from your map legend, take a tour, toggle, edit trip, custom, walk slash, powered, man, swap, cap B, and address, text field. Insertion point text, numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9.
So
8, 7,
the
6,
user is
7, 8,
using
9, 0,
an on-screen
0,
keyboard to enter an address for the router.
Map legend. Start route from your location. 3960 Benton Lane Northeast. Seattle. Unchecked.
And
Edit trip
now,
planning profile. Toggle display. Take a map legend. But start. Zoom in. But start route from your location. Button. Zoom in. Zoom out. Route. 343 meters. 9 minute. Trip info. Button. Navigate. Button. Trip info. Navigate. Button. Continue. Slide right and use the pedestrian. Start by heading west.
and so now after routing, using the on-screen keyboard, he's able to go ahead and follow the path.
Heading level 2. 2. Continue straight and use the stairs. Start by heading west. Use the pedestrian path. 2. Continue straight and use the 2.1 meters.
And the distance information tells you how long that segment will persist.
Slide right and use the pedestrian path. 16.2 meters. Use the pedestrian path. 2.1 meter. Slide right and use the pedestrian path. Continue straight and use the footway. You will pass by a university building on your right called Mechanical Engineering Building. Walk. You will pass by a university building on your right called Mechanical Engineering Building. Screen dim. Continue straight and use the footway. You will pass by a university building on your right called Mechanical Engineering Building.
And at this point, he's not trying to go step by step. The narration will advance. The narration advances as he moves in space. So it follows him. He doesn't have to actively maneuver the screen reader to do it.
Continue straight and use the pedestrian path. 18.0 meters.
So a couple of things about the narration. Where available, we do use landmarks
Slide left and use the footway.
as orientation indicators, and it will
9.4
tell
meters.
you how far those landmarks might be from where you are.
Turn right and use the sidewalk. You will pass by a university building on your left called Low Hall.
And building demarcations are annotated as well.
Continue straight and use the sidewalk. You will pass by a university building on your left called Low Hall. Screen dim. You will pass by a bench on your left in 14.0 meters.
So at that point, he changed the access
Image.
to the hierarchy to identify additional details about the path that he's on.
One 1.3 meters. Continue straight and cross the street.
So there was a GPS lag there where it caught him in the crossing. When
Continue
he
straight
was
and use the
already there.
sidewalk. Screen dim. You will pass by a university building on your left called Mechanical Engineering Building.
All right, I think at this point we can have you start explaining what's actually happening there in terms of the design interaction. So please welcome Kunal Mehta, who is one of our user experience and UI personnel, designers.
Awesome. Thanks, Anat. Yeah, we tried to do the demo video last week, and weather wasn't great, unfortunately. So I want to quickly talk about some of the aspects that went into designing the non-visual experience or the screen reader mode. Before that, I want to take a moment to just talk about screen readers and specifically how they work when somebody uses a mobile. Mobile phones are typically touch screen these days, and a non-screen reader user would typically look at an element and tap on it to activate. But for somebody who's using a screen reader and somebody who cannot see the screen, how it works is you typically explore the screen, you tap around, when you tap once, you hear what it is, and when you know the element that you're on, you double tap on that, and then it activates. So it takes that extra few milliseconds or maybe a second to kind of navigate, and that is something we've kept in mind while designing the experience. So the first bit is previewing a route. So first thing I typically would do is I would want to check out a particular route. On popular apps, there are aspects that are very visual. So you might see the whole route and how it looks. And there are also apps that are screen reader friendly, and you can potentially check out or preview the route. But there is a lot of detail involved, and you're not able to skip past details. So, for example, if I want to preview a route, I might just want to look at the directions, and I don't really need the street names at that point of time. But then I would still have to go through the entire information of the street name, of anything else that is present over there. So with AccessMap Multimodal, what we've tried to do is we've used the HTML semantic markup and made sure that people are able to navigate by information they need. We have a quick demo video of me using trying to use the navigation feature by information hierarchy that I did on my computer a few days back.
ZB connected WF. Access map dash Google Chrome. The access map dash memory.
I'm trying to traverse or look at the path that I need to traverse.
Use the sidewalk heading level 2.
Let's first explore only the directions, and I will use the heading 2 command with my screen reader. The reason I'll able to do this is because each of the directions are tagged as a heading 2.
Turn left and use the sidewalk heading level 2. Continue straight and use the sidewalk heading level 2. Turn right and cross the street heading level 2.
You might notice that it is not reading any other information such as landmarks and the street names because I'm only using heading 2 to look at the directions.
Turn left and use the sidewalk heading level 2. Turn right and use the sidewalk heading level. Turn left and cross the street heading level 2. Continue straight and use the sidewalk heading level. Continue straight and use the sidewalk heading level 2.
Now let's say I want to look at the street name and the associated direction with each of those street names.
Sidewalk S of Northeast 45th Street heading level 3. Continue straight and use the sidewalk heading level 2. Sidewalk W of Brooklyn Avenue Northeast heading level 3. Continue straight and use the sidewalk heading level 2. Sidewalk W of Brooklyn Avenue Northeast heading level 3.
Now you might have noticed that it's reading the direction and the street name. This is because I'm using the heading at the third level.
Continue straight and use the sidewalk heading level 2. Sidewalk W of Brooklyn Avenue Northeast heading level 3. Continue straight and cross the street heading level 2. Crossing at Brooklyn Avenue Northeast heading level 3. Stop share left parent Alt plus S right parent button. Alt C. Zoom. Are you sure you want to stop recording to the cloud? Enter. Stop share left parent Alt plus S right parent. Alt S. Sorry, I didn't realize it was so fast when I recorded it. So once I'm done previewing a route, what the next obviously natural thing would be to navigate a particular route. And for navigation, generally there are things like signages that aren't very useful for people who are blind or low vision. So we've tried to incorporate landmarks that are tactile in nature, landmarks that could be present in people's field of view for somebody who is, let's say, using a white cane or even a guide dog. So we included landmarks like, and you might have heard these in the first video where it said you'll pass by a bench in certain meters or by a wastebasket after a few other meters. So basically, these are non-visual or tactile landmarks that people would encounter on their way while navigating. The next aspect is that AccessMap Multimodal facilitates spatial awareness. You might have heard the screen reader say you will pass by mechanical engineering building on the left and another building on the right and stuff like that. I was typically trying to navigate to another building from this building, another building on campus, and those were the buildings that I found on the way. Now, I would generally navigate from point A to point B, be it pedestrian or be it taking public transit or whatever that might be. But I wouldn't really know what are the other buildings or other spots that are around, and having this information helps me understand where my building or my point of interest is with respect to these buildings or these points of interest that I come across. And more importantly, it helps in comprehension, because although I might not memorize that mechanical engineering building is somewhere here, but I have some idea as to where it is, and when I want to probably traverse the path next time, or if I need to ever go to mechanical engineering building, I at least have some idea as to where that might be. The next feature is the specific directional cues, because sometimes abstract directions such as turn left or head east can be a little confusing. If the app tells me turn left, I might turn left about 90 degrees, but then let's say the actual turning was about 135 degrees or 30 degrees or 40 degrees, I would kind of encounter a barrier. So with AccessMap, what we've done is made directions more specific. So that could be, it could be turn sharp left. So sharp left would be about 130 or 140 degrees. The regular left command would be 90 degrees, and slight left would, let's say, be 30 degrees or 40 degrees. And
that helps somebody gauge as to the turning that they need to make. Next one is my favorite. It's to do with milestones and validation. So when when I'm traversing, and I mean, let me back up a little bit. So when I say milestones, I mean it could be anything: a landmark, a destination, a building that I'm passing by. It could be anything. And when I'm passing by these these milestones, I have that information, but more importantly, it also helps me validate. So, for example, last week I was navigating, and there was a 41-meter stretch, a straight. But then it told me you will pass by a bench in 12 meters, and that I think for me was very important, because otherwise I would have traversed maybe 30, 40, 50 meters, and it could have been that I probably took a wrong path. But now the only thing that I need to look for is a bench in maybe 10 to 15 meters approximately. So and if I don't find the bench, I can course correct much before instead of going the whole way and then trying to course correct and find my way back. So yeah, that's a personal favorite. Obviously, we realize that customizability is important, because not everyone would want all alerts at all times in all situations. So the idea is to slowly build the system in a way that people are able to set what alerts they need, what they don't need, both at a profile level, which would be their default setting, and at a trip level, because you might want something for a particular trip, but not by default. So currently, all everything you heard on the video are alerts. There wasn't anything that I was doing except once or twice when I was just trying to save my phone from being locked. So yeah, and the idea is also to make sure that each card that you're navigating is accessible to somebody who's using a screen reader, and this is in the pipeline. We're trying to figure out how we could make each card accessible while you're traversing, and each card. Basically, the user knows the card that they are kind of traversing, equivalent of looking at whatever is in focus for somebody who is seeing the screen. Finally, I know Anat mentioned about the pilot, the beta. We are looking forward to doing the study with more users, more participants, and iterating the experience based on the feedback. So please do sign up, and we'll look forward to get your feedback. Thank you so much.
Awesome. Thank you. Any questions about any of the things you've seen today? Yes.
How are you collecting data on the smaller landmarks like benches and trash cans?
Yeah, great question. So we mentioned two things. One is that for the actual graph itself, we are publishing our own apps that interact with the underlying graph information. In addition, we're grabbing a lot of information from OpenStreetMap. So people are out there, and there are some very avid mappers who put down every bench and every trash can, and we are beneficiaries to a lot of that open public effort. We're also actually collaborating with OpenStreetMap and Meta in doing those collections and getting more mappers out there to collect that data. So this is more about the landmarks, but not the graph itself, which we mentioned earlier. We're asking people to go through our app to comment, give us data verification, refute the data if they choose to. Thanks.
What's the precision of the actual location?
So the question was, what is the precision of the actual location? And the answer is it depends. So if you're talking about the GPS location precision, it's typically dependent on the phone GPS. We do have some users actually using a dual, an external GPS device that pairs with the phone to improve access to satellite information. But that's, mappers that we engage. People like general crowdsourcers may not have that level of precision. As it comes to OpenStreetMap, the editing capacities also depend on what editors people are using. So if they're using like a desktop editing application, then typically it's just aerial imagery, and so they're mapping based on the aerial imagery that's there. If they're on land and actually on location, then again, it depends on the phone that they're using and how accurate that is. So it will vary. What's actually, to ask Kunal a question, what's been your experience now that you've used the Seattle data pretty extensively? Like how accurate has the information about like trash bins and fire hydrants been?
Yeah, I think I'm yet to encounter a serious glitch where I find that this doesn't exist or something on those lines. So yeah, I'm yet to encounter.
Thanks.
If the map uses the phone camera, or
Can you please use the mic or wait for a mic runner?
the app, does the map use the phone camera?
Does the app use the phone camera? Not for, you mean for orientation and heading? No, not this time. Anyone else? Okay. Yeah, so if that's it for questions, we're super excited to launch this. We hope to partner with most of you in the room because a lot of you have access to data, have access to local communities and lived experience within those communities. So please do join us and contact us. Let me put that information back up. Anything from Zoom? Okay. There we go. So please join us.